Alright, it's Mr. Sullivan. I'm back. We're on 11.2, the negative and Pythagorean identities edition of Mythbusters. We are going to bust some myths about things dealing with Pythagoras, and we're going to talk about, more importantly, the Pythagorean identities and how we can use those to solve some trig identities. So, myth number one. Pythagoras was so great and smart that he could write on the moon. Alright, he told his friends, I am so powerful I can write on the moon. That is actually busted. Sorry, Pythagoras. He was actually very smart, and what he did, he would write in blood on the back of a glass. He'd write on the moon. He'd lift up the glass, tell his friends they had to look through the glass, and they'd see the writing, and they'd think, voila, he wrote on the moon, because obviously they just weren't that smart. So, tricky, but not true. Myth number one is busted. All right, so let's take a look here. The very first thing we're going to talk about today are identities for negatives. All right, we'll sometimes get some negative angles in here. So let's see what we have here. Sine of negative x equals negative sine of x. Pretty straightforward. These are things you just need to learn, all right? Along those lines, what else goes with sine? Cosecant, right? So the cosecant of negative x is negative cosecant x. All right, cosine of negative x equals the cosine of x. So in this case, it's the same thing. The negative really doesn't affect anything. And along those lines, same with secant. The secant of x equals, the secant of negative x equals the secant of x. All right, so when we have cosine and the negative inside, it comes out as positive. When we have sine, negative inside, or it comes out as negative. Tangent of negative x is a lot like sine. It's going to come out as a negative. And think about it, sine over cosine, this has to work, right? Because it comes out negative, it comes out positive. Negative and positive is going to make it negative, and that's what tangent is. So this also will work with cotangent of negative x is going to be negative cotangent x. All right, so these are things you just need to learn, have it involved in your memory. All right, let's try some. Reduce these to a single trig expression. All right, well, this one's pretty easy. The sine of negative x, we already said, becomes negative sine of x. The cosine of negative x, we already said, comes the cosine of x, positive. So a negative divided by a positive is going to be a negative, and sine over cosine, that's going to be negative tangent of x. All right? Over here, we have a little bit trickier. Let's work with the negatives first. So tangent of negative alpha is going to be negative tangent alpha. And cosecant of negative alpha, that's like sine, remember? So that comes out. That's negative cosecant alpha. A negative times a negative is a positive. So let's work with these. This is going to be sine alpha over cosine alpha times cosecant is 1 over sine alpha. These cancel, we're left with 1 over cosine alpha, and reduce that down to, what is that really? That's secant alpha. Alright, so we reduce it, start with some fancy stuff, and reduce all the way down to a single trig identity. Now sometimes, please understand that sometimes when I ask you to reduce that down, you're actually going to reduce it down and get the number 1, or the number 2. Alright, just a single term. Alright, so here is the identity, the Pythagorean identity, all right? This is a big one. Sine squared plus cosine squared equals 1. Remember, a squared plus b squared equals c squared. You can see what that gets. You do that on a unit circle, you're going to get sine squared plus cosine squared equals 1. If you want a proof for it, Mr. Bean would love to spend 20, 35 minutes on it, show you all the intricate details of it, and just bore the pants off you. So please, go ask Mr. Bean for it, and he will do that for you. All right? And ask him, Mr. Bean, can you show me on the board? All right? I need to see it on the board. All right. So here we go. Now, this alone is really powerful. In other words, anytime I see sine squared x plus cosine squared x, I know that I can plug in the number 1. That's a big one. All right? When we're simplifying identities and things like that, it's a nice thing to have. But there's another really great thing about this. I could subtract cosine squared, and whenever I saw sine squared x, I could put 1 minus cosine squared x. Or likewise, if I saw 1 minus cosine squared x, I could put sine squared x. Same over here. If I subtract sine squared x, I know that cosine squared x equals 1 minus sine squared x. That's big, all right? Or if I see 1 minus sine squared x, I can substitute cosine squared x. So while this is the big deal right here, it leads to a lot of other possibilities, which are really phenomenal, all right? And it leads to a couple of other things. The first thing is, watch this. We have two more identities. Now, I'm going to give them to you. A lot of teachers don't give these to you. They think, oh, well, they can derive these formulas all the time. All right? They don't need to memorize them. Well, what's the point? All right? Let's derive them right now. I'm going to divide everything here by cosine squared x. I can do that. All right? I'm going to derive everything, divide everything by cosine squared x. Well, sine squared divided by cosine squared, that is tangent squared x. All right? Cosine squared x divided by, that's 1. And 1 over cosine squared x, that's the same thing as secant squared x. So now we have another Pythagorean identity. All right? And you should probably write that one down. It's a big one. All right? So it is tangent squared x plus 1 equals secant squared x. All right? And along those same lines, if we had just tangent by itself, we could subtract 1, right? We could have tangent squared x equals secant squared x minus 1. So that's another thing we could substitute in. I see secant squared x minus 1, I can put tangent squared x. I'm giving you gold here, people. I'm gold, all right? There's one last one that comes from this Pythagorean identity, and again, a lot of those teachers out there, they're academics, they're higher thinkers, they're really smart guys. I totally appreciate that. Here's the thing, I want to make this manageable for you. Why would I make you do this every single time when the secret's out there? Here's the secret, right? Instead of dividing by cosine squared x, what happens if I divide by sine squared x? What happens? Well, this is what happens. We get sine squared over sine squared is 1. Cosine squared over sine squared is cotangent squared x. And 1 over sine squared is cosecant squared x. All right? So we have now really 3 big ones. All right? And then manipulations of those, we have plenty others. When I say manipulations, again, cotangent squared x equals cosecant squared x minus 1. All right? We have a lot of great information out there that we can use. So let's see how we can use this stuff. All right, reduce this to a single trig ratio. All right, here's hot tip number 1. Write everything in sine and cosine. All right, well, I'm going to do that. Tangent is sine theta over cosine theta. All right, times cosine theta divided by cosecant is 1 over sine theta. All right, that's easy enough. So now let's see. Oh, this is nice. These cancel, so now we have sine theta divided by 1 over sine theta, right? When I divide by a fraction, that's the same thing as multiplying by the reciprocal. Sine theta times sine theta is sine squared theta. And there is our single trig ratio, all right? So I reduced everything to sine and cosine, did some fancy math from algebra, actually fractions, 8th grade, 7th grade, 6th grade, and I came up with my single trig ratio. Now this brings up a fair point. X times x is x squared. Sine theta or cosine theta or whatever, tangent, when you multiply those together, we write that as sine squared theta. We do not write that as sine theta squared. It is not the same thing. It's sine squared theta. In your calculator, you may need to write that as sine theta, group it all around, and square it. All right? But this is how we write it. Okay? That's a really, 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 really important note for you to understand. So, myth number 2, Pythagoras actually discovered the planet Venus. That is confirmed. It's true, he was the first person recorded to discover the planet Venus. Pretty cool, actually, if you think about it. He didn't have a lot of the fancy technology that we have today to look at the stars. He was the first one to discover Venus. Way to go, Pythagoras, you're my boy. All right, verify the identity. Ooh, we got another hot tip. Hot tip! Look for an identity. Ooh, look for an identity. All right, now, here we go. Sine squared plus cosine squared equals 1. Remember, ooh, look at this. 1, if I subtract this, sine squared is the same as 1 minus cosine squared. Okay, this is what we're talking about. This is an identity. It is equal to sine squared. I am plugging that in right now. Sine squared over cosine squared x. What's that equal? Sine over cosine? Well, that is tangent squared x. And that equals tangent squared x, which is we wanted. And there we have it. We have verified it. We have proved it. We are amazing. Let's take a look at the next one. Hot tip! Hot tip number 3. Use algebra to make equivalent expressions. Oh my goodness. We love us some algebra. Here's what we're talking about. A lot of algebra we've been doing already, but this, we can factor this. Sine squared, this is like x squared plus 2x plus 1. If we were going to factor that, that would be x plus 1 squared, or x plus 1 times x plus 1. It's a perfect square trinomial, right? So let's write that with sine. So that is sine alpha plus 1 times sine alpha plus 1. All right? And we're going to divide that by cosine squared alpha. Remember to keep in track here, we want to get it to 1 plus sine over alpha, or excuse me, 1 plus sine alpha divided by 1 minus sine alpha. All right? So let's take a look here. What can we do? Well, again, we have cosine squared alpha. I remember that's my identity. When I have cosine squared plus sine squared equals 1, I know that if I subtract this, get cosine by itself, it's 1 minus sine squared. So I'm going to rewrite that. Sine alpha plus 1 times sine alpha plus 1. And on the bottom, it's going to be 1 minus sine squared alpha. All right? Now this is difference of squares. It's like x to the second minus 9. Difference of squares, that's x minus 3 times x plus 3. Using algebra again. So now, here's something else. We've talked about this. Keep this in mind. Can I rewrite this side a little bit like that? I can. So I'm going to just rewrite this as 1 plus sine alpha, because I think that'll help us in the future. 1 plus sine alpha. All right. So this is difference of squares, as we talked about. The square root of 1 is 1. The square root of sine squared is sine. So it's 1 minus sine alpha and 1 plus sine alpha. Ooh, good thing we did rewrite that. These cancel, and it gives us what we wanted to prove. 1 plus sine alpha divided by 1 minus sine alpha. And it does indeed equal the other side. That is a horrible alpha. I alpha apologize. Anyway, it is verified. We did our job. We used a lot of math in there, a lot of algebra, but we did it no problem. All right, myth number 3. Pythagoras was not actually the first person to discover and prove the Pythagorean theorem. This well-known theorem, a squared plus b squared equals c squared. He was not actually the first person to discover it. That is actually plausible. There are many different instances where societies and cultures prior to Pythagoras being on this planet, and they would write Pythagorean triples, 3, 4, 5, 5, 12, 13. They had that, they knew about that. So it is very plausible that he indeed, although he's named after him, did not come up with the Pythagorean theorem. All right, so let's take a next one. Hot tip number 4. Combine the fractions. Combine the fractions. Let's see what we're talking about here. All right, I'm going to use hot tip number 1. I'm going to rewrite all this in terms of sine and cosine. So this is cosine x over sine x. And then we're going to multiply that by cosine x, which is cosine x over 1, plus this is sine x over 1, right? So this is just cosine squared x over sine x. We're multiplying, plus sine x over 1, and we want to keep in mind we want to get to cosecant x All right, now I don't always write this on the other side, and I apologize. That's just me being lazy. All right, so if I want to get a common denominator to add these, I need to multiply this by sine x. So I have to multiply sine x on top and bottom. So now I have cosine squared x plus sine squared x. That's on top. We have a common denominator of sine x. So that goes on the bottom. All right. Identity alert, identity alert. Cosine squared x plus sine squared x, what's that equal? Oh yeah, that's a 1. 1 over sine x, and we know that 1 over sine x is indeed cosecant x. There, we done did it. We verified it. It's all good. All right? All good, all good. All right, myth number 4. Pythagoras had a brotherhood, almost a cult-like following of students who went to him to study. And we're pretty sure this is what those guys look like. Pretty sweet, pretty awesome, right? That is confirmed. All right? He had a whole thing. It was almost a secret society. All right? He would make people go for 3 years before they were actually really allowed into his secret society. All right? You know, pretty cool guy, apparently, he thought he was. A little bit high on himself, so I guess, you know. All right, so bring the pain. Let's try this one here. See what we can do. We got tangent squared minus sine squared equals tangent squared sine squared. All right, I'm going to go over here. I'm going to start with my very first tip. I'm going to convert this to sine and cosine. So sine squared theta over cosine squared theta minus sine squared theta over 1. All right. I am going to try and combine these, so I need a common denominator. I'm going to multiply this by sine squared or cosine squared theta. All right. So over here we now have sine squared theta minus sine squared theta times cosine squared theta. Can't really do anything with that just yet. All over our denominator of cosine squared theta. And remember, we want to get to tangent squared theta and sine squared theta. All right, now, something I notice here. I have a couple of terms, and I have the same thing factor in both terms. To me, that means take it out. Greatest common factor. So sine squared, I'm going to factor out. So sine squared theta, take it out. So I have a 1 minus cosine squared theta all over cosine squared theta. All right? Now I'm going to separate these. I'm going to put this together over here. Sine squared theta over cosine squared theta. And I'm going to multiply that by 1 minus cosine squared theta. Why did I do that? Well, remember where we're headed. We want two things to multiply together. So I have one thing here, sine squared over cosine squared, which is tangent squared theta. Ooh, that's great. And what do I recall? Sine squared plus cosine squared equals 1. Sine squared equals 1 minus cosine. So 1 minus cosine squared right here, that's the same thing as sine squared. And boom, that is exactly what we wanted. Yay, us. All right, verified. All right, this one is really, it's hot. It's hot in the kitchen. If you can't handle the heat, get out, right? I want you to pause the video and try this one on your own, all right? All right, my recommendation to you right now is to listen to me, pause, write it down. Listen to me, pause, write it down. I've separated the steps so it's kind of easier to follow me that way. But this first step, what I did was I made it all sine and cosine. Then I got common denominators on top and bottom so that I could combine those fractions. All right? So this is just that step of combining them. Sine x times sine x is sine squared x. Same thing over here, cosine squared x. So on the top I have sine squared x minus cosine squared x over sine x over cosine x, or excuse me, alpha. And on the bottom, sine squared alpha plus cosine squared alpha. All right? Now, from the green to the blue step, from this step, what I did was I just changed from dividing a fraction to multiplying by the reciprocal. And when I multiply by the reciprocal, I could cancel out the sine alpha, cosine alpha here and here. I knew that sine squared alpha plus cosine squared alpha equaled 1. So that left me with this right here. Sine squared alpha minus cosine squared alpha times 1, which is just really sine squared alpha minus cosine squared alpha. The last two things I did was I took my sine squared and I changed that using my Pythagorean identity to 1 minus cosine squared alpha minus cosine squared alpha, and there's just combined like terms. I have 2 negative cosine squared alpha, so 1 minus 2 cosine squared alpha. Alright? I like trig identities a lot. They're a lot of fun to play with. There's no one right solution to do it. There's a lot of ways you could do it. You could make them a lot harder than I did. You can make them easier sometimes than I do. The key to remember is this. You got to show your work. You can't jump around. The work is the answer. All right, the work is the answer, and you need to show that. So, I wish you all the best on these trig identities with the Pythagorean identities, and I will see you on the flip side. Peace out.